robotic, buddy?
Not now. Go on.
So string, the S is caps, is lowercase, is uppercase, sorry, because it's a module as well.
Oh, so this there's a
And
dot in
then the
here.
function, sorry, in string in our case.
In stream.
Yeah.
In
No,
stream.
after this is string IO, and then the function is makes in string. I'll type
I
here for you.
I think it's my internet now because now the we are dropping frames.
Let me see on Twitch.
We dropped frames. We are
I
still
mean, on
dropping
Twitch
a
it's
bit.
fine. Not like there is anybody watching anyway, but
No, there is. There's a number three in here.
well, one is me.
One is me. There's a bot watching it. Then.
I opened the stream for a moment. Maybe just didn't realize I closed it.
And then you're gonna send the reader. There. Okay, so
Do you return the
ooh,
stream?
that's modifying in place.
Yeah. So I think that we need to do
So,
this.
no, that's already modifying. You don't
Oh, so this returns unit.
exactly. It's seeking,
Ah.
right?
Okay, so it's
It's mutability
really
on
mutating. Okay.
steroids. Yeah. So okay, now to read it will be stupidly easy because it will be just go on the man delete all of this crap on the get. Actually, without keep the open, we're gonna need it, but
Uh,
delete all the other crap like the
uh,
val.
raise, fail,
Ah
error,
man, why do you handle
seek.
errors? Who cares?
Okay, delete everything in here.
No. 7 and line 31. We're
Uh,
gonna use both.
I could not. You chopped it a bit, so I'm gonna just do
Line
this.
27 and
27.
31 you should keep, but you deleted 31.
I deleted 31. I should keep this. You said
Yeah.
27. I should keep, so I should get rid of this.
Yeah, and the set pause as well.
Okay. We're gonna do seek here, right?
Exactly.
So it's
And
gonna
then just as
be
initial
in
offset. There.
stream and initial offset. There.
That, and then we read the input, and then put 6 there. I don't know, something big. Now try calling this again from the get.
Uh,
Go back to the. I think it's our handling. There's the types probably are inconsistent. Go back there.
back where here?
Yeah.
Okay.
So comment the read, man.
Comment the read.
Actually, the read data is the one we want. Sorry. Comment the write, right? Not the read.
Sure. Comment the right.
Wait. It didn't even check the rest,
The
man.
same thing.
Yes, but
So
let me read, man. Check the rest.
broker SML22 match expected, but pipe was found.
Go back, man.
I think the syntax is wrong. I think
Pipe on the first. You delete it. You don't have
pipe
pipe on
on
the
the
first.
first.
Yeah, you don't have this.
This you mean?
Yeah. Actually, the best case is put the off on the next line, and then you
Oh,
just do
like
the.
this?
Yeah, I do that because then the syntax stays aligned. You see.
Uh-huh. So
Uh,
is this what you want? Is this correct?
yes, but wait. That's not all. Everything. Go back to the main. Let me see what the heck we're doing there.
As far as I can tell, we are just calling
Delete. Delete
delete.
that crap on the handle. Like
Which one? Which crap? This
everything.
one?
Everything on the
Oh,
handle.
everything. Here.
Yeah, just this, and then this should return bytes, right?
It should.
And then we're gonna make a string out of the bytes and then print. Let's see.
Yeah. Uh, nope.
The heck is wrong,
So,
man?
uh, what is the problem? Broker 26 and expected but fun was found. Oh, I didn't put and at the end of the new
Oh
function.
yeah, I forgot. It's a syntax.
I'm very
If you do
inclined
a
to
tab,
fixing the heck is going on with this mode.
do a tab on the end.
Do a tab.
Yeah, it will tab correctly. Like,
I'm pressing
yeah,
tab.
it indents. Yeah, because it's already indented correctly. But
Okay.
like, yeah. Um,
No.
okay,
Do
now try
we
running.
have a thing? Oh yeah.
We
Okay, so just run.
no, we need to do execute instead.
Execute.
Nix run dot slash
Oh, this is
execute.
because of the flake.
Yeah.
Okay, so that's true. Execute.
No, it's Nix run dot slash execute.
Dot slash
Execute.
execute. Like this?
Mm-hmm.
I see.
Because you're summoning the function inside
Okay,
the.
so just run.
What?
Are you sure it's Nix run execute?
Yeah, absolutely. Dot
Uh,
slash, right? You put.
oh, I put hashtag, sorry. Slash.
No, it is hashtag. Yes, that was right.
Uh,
Execute, yes.
execute.
Can you
I'm
try running the command instead
sure,
of just?
sure.
Although it's the same thing, right?
Yeah. No, but this
It
worked.
worked. Yeah, okay.
What
So
the
do
heck
you
is
have the
going
file?
on?
Do you have the file to begin with?
No, actually.
So create one. I think we're using account because we picked from the
Oh, you're
database.
using ABC.
Oh, I don't think we
ABC.
committed ABC. Right?
ABC. We're gonna put something like.
1, 2, 3.
Sure. No, we put 6, right? So.
I don't need to put all the way there. So it is reading bytes. I think bytes have a function. Can you? Let me type here myself.
I can't. How is the just failing though? This is exactly the same crap.
There is a byte to string on the byte module. On SML. Right?
Um. No, now it works.
Yeah.
What?
So it was the problem that we were not mutating the thing and reading less than we should. Go back to SML. Go back.
No, that's not it. Which one, broker or main?
Hope that's not SML. Go this. You can go to main. Yeah. In the read data, compose this function with a byte, like module.
Uh, I don't have this, right?
You want to define a pipe?
Yeah, that's what I was about to say. Can I define a pipe?
You can.
Should I
Yes.
do it? Is this the way, or SML people prefer another way?
People don't do it because, as I said, it's not preferred to do currying, right? But I find that the thing like kind of meh. So I would do it.
Okay, so how do
How
we do
you
it?
define it though is, let me just remember here how to do in
You
fix
have in
because the
Perplex, I
syntax
think.
is. I do, yeah. If you can open the project, I think I have there.
Uh, I
Just copy it because the syntax is horrendous.
okay, so let me go to
And I picked from
Perplex.
someone else as well. I don't
You
remember who.
pick for someone else, of course. Let's go and bring. I'm gonna open a new browser here. Perplex.
I got it. It's here. Let me send on Discord from my laptop.
You're very happy today, Magetta. Is everything alright?
Because it's Friday, I don't have to work tomorrow.
I had you here other Fridays, and you were not this happy.
He's usually tired, right?
Yes, I'm
I
usually
think
tired. Yes.
I
yeah,
believe,
same
Marin,
with
that he's still tired now, but he's
I
very
am,
happy.
but I'm less grumpy. I gotta say.
Okay, I like that. I like this new Magetta.
So
Uh,
that, yeah, this syntax is beautiful as you can see.
uh,
By the way, the fun is indented after the infix. Okay, so it's like 2 by 2.
So it's this.
No, I mean like the infix. It's in pairs, right? So it's infix fun, infix fun, infix fun.
Ah,
I
I
mean, it
guess.
doesn't matter because SML is not sensitive by
Okay, to be fair, this
indentation.
is ugly, but it's defining more than one thing at a time. It's defining four.
Yeah.
I have a
So
question.
Go.
comedy.
Why the forward pipe specialized to pairs?
You mean these
Uh,
pipes?
oh right, this is something we have in F sharp, and I thought was good because it just uncurries a tuple. Right? It curries a tuple. Sorry.
Yeah, it carries a tuple.
But can't you just do the same thing using the normal forward pipe?
Yeah, that's what I'm thinking, Magita.
Oh wait,
Because
that's not the same thing. Yes,
yeah,
that's
I
right.
think what you want is
What I wanted
this.
was this. Yes, exactly.
Ah, okay. So yeah, I see. Good catch, Marinho. Good catch.
Yeah, I didn't notice.
Okay, so
I
in
think I
this,
never used it. That's why.
come on, man, come on. Okay, so then, indentation. Uh, no, no, the
I
snippets.
forgot the.
No, the snippets,
Oh,
man.
oh man, don't you wanna go through Visual Studio?
Ah, uh, I'm gonna commit and then you start the session
Yeah.
there. Uh,
Ooh, I'll just
so
have to run the sudo because I'm on macOS.
add seek function to data module. Push.
Maybe it was because I was playing on my Dreamcast yesterday.
Oh. Oh, so that's why he's happy because you're
Yeah,
playing
I was
Dreamcast.
playing Skies of Arcadia, which is a good RPG. Although I would pair with the Empire of Valua to destroy all the world in the name of the Spanish Empire.
I see.
Anyway,
Okay, so I removed my screen from the stream right now because I'm gonna wait for your token, Magita.
right.
I
I
can't
downloaded the.
believe that thing is better on VS Code than Emacs.
Unfortunately, it is. Yes,
But we
quite
gotta
sad.
fix that, man. Like, didn't
We
Zosing
have
made
to.
his own, like, implemented, like, improved the Ada mode for his project? We could do the same.
Probably it's just Zosing using the Ada mode though, but probably just us using the Emacs mode as well. Okay,
uh,
so open folder. Where's the project?
and you need to do a git pull as well.
And that I will do on Emacs because I don't even know the Git stuff anymore.
Yeah, that's a problem. That's a skill issue.
Why? I just know Magit. I just don't need
Because
to get out of Magit.
when imagine the situation, Marinho, in which Mageta needs to make a Docker image, and
I don't know how true anymore.
he's gonna put Emacs inside the image just to use Magit.
Yeah, of course I remember. I'm exaggerating, but
No, but I could imagine you doing that. That's the funny part.
is that funny? Why is that funny?
Because it's so you. I'm just gonna add Emacs because Magit is like stonks.
We had Emacs deployed on a service in my company because it was more convenient.
Wow.
Okay. And then there was like this guy complaining, "Oh no, what about the vulnerability, man? Like there are people committing passwords. Like I think Emacs is the least of
Oh,
the problems there."
people committing passwords.
Yeah, man.
That's a thing.
People commit passwords all the time and no one cares. Like, and their analyzing tools don't get it, which is the worst part.
I don't know
Wow.
what's worst.
Okay, here.
Did
Is
you
it
share
too
the token?
small? Is it too small?
Uh, I would like to join the session here.
Yeah, I still need to download the extension. Just give me a sec, because I
Oh,
just
okay. So
downloaded
you
VST.
said VS Codium before. Oh, yeah, I
Yeah,
remember.
but we can't do this on VS Code, mate.
Maybe they fixed it. Who knows?
Do you think they did? Yeah. I think it's not about fixing. It's because it's unfree, right?
Ah,
Libre.
I thought the protocol would be available.
No, it's definitely not a protocol, man. It's a Microsoft service.
No. Okay. Okay. So
Okay,
here's
let me
the link.
close.
Copy.
Yeah.
Copy this. Um, join. Okay. I'm joining.
Now let me. Did you pull? Did you push?
Yes, it's already in master. So let me put my screen back on. There we go.
Okay, it's this code here, right? I didn't see.
I still don't have highlighting. SML.
Download melee mode.
Melee mode.
Not melee mode. Just melee. This one here.
Oh, okay, I found it. There's only one.
Yeah.
Uh,
Stop reading right.
There can be only one.
There can only be one. Let me increase the size because maybe
oh,
the
it's much
audience.
better. It's much better. And I happen to have configured the theme to be mine. Ah, okay, I loved it. Okay.
Don't love it too much. It's not Emacs.
Yeah, it's not
Doesn't
Emacs.
deserve it.
But come on, the indentation is too broken.
It is. It is. I agree.
Okay, let's go back to the
Okay, so
name.sml. Now let's do our shiz. So what do we want to do after piping?
after this, we want to do a bytes. So there's this byte to string. That's it.
No. Okay,
And
you are the
then,
one hosting it. You need to run it.
can you guys see my terminal
Yes,
here?
yes, we can.
And then I need to do this. So don't cringe, please.
Yeah, I'm cringing already. It's really weird.
All of this can fail in the end.
Wait, what happened there? Linker command failed.
I don't know. Poly playing. Oh, I think I know. Oh man, ARM. I hate ARM.
Oh, it's an architecture problem.
Let's see if it is. Just a sec.
That would be bad. Couldn't
I
we fix
mean, I
this with
can just
Nix though?
swap.
Are we using the Uchus thing?
Just a sec. I can swap here, so that's not a big issue.
Swap the computer?
Well, no, but I can certainly swap the poly implementation.
Oh. Uh, okay.
Hamilton. How do I have SML, man? Do I have any SML implemented stored here?
I have no clue.
I don't. Okay, so I'll add poly, and we're gonna leave happy. Because I love poly. Who doesn't love poly? And let me add melee too. Although it doesn't matter, I guess.
Oh, apparently when you do infix operations, it's also inferring the type. That's cool. Yeah.
Okay, so update. Please just work. I don't want to spend much
Wait,
time
but
here.
what are you doing exactly?
Just adding globally on macOS polyml so I can run the
Oh,
command instead of
so instead of modifying the flake, you are installing it globally. Sure.
which is what I do on macOS because then I don't have to use sudo, right? And I can swap the architecture that way.
Yeah, but wouldn't it be better to just use the Uchus thing for the flake?
Um, it would, but the problem is that I still have to run with root
Oh, okay.
in that case. So
Yeah,
it's
that's
still
true.
a pain.
That's very true.
Uh, Let's just download 1 GB. So I'm just finishing.
How did Homebrew does not have this problem though? Do you know?
No idea. I think it installs globally in OPT partition.
Oh, I see.
Okay, so can I run now? So cat flake Nixu. When am I doing this?
You're gonna just gonna copy the build command.
Is it just policy from what I can see? Oh, and we're gonna do uh, totally not Kafka build SML.
Okay, let's see if this works.
Taking long, so it's probably working.
Uh, that's a little bit concerning. It's taking all this time to do very little stuff, and it
Oh,
broke.
I
start
mean,
this
as long
terminal?
as I have LSP, I don't need to run, right? So, okay,
What a Chad.
I've been doing code like this on prod for a month now, and
Nobody's
I just had
complaining,
my
I
first
guess.
bug. I had my first bug in a month.
Okay, let's suppose that all of these three functions are working.
Yeah,
So,
well, the set will not work. We have to adapt it to. So we have to do
uh,
like this is the thing I didn't like. We have to do a this type is not polymorphic, right? So
ooh, the type
yes,
is not polymorphic, bro.
funny, isn't it? Isn't it?
I'm disappointed.
What we can do, however, is something like this: data type string
Marinho, did you get why this is a problem? Why it's so cringe?
in out.
Marinho, are you there?
Uh, yeah, actually, I kind of missed out on that detail.
Okay, so do you want me to explain it or I can explain?
I do actually. I
Okay,
do actually.
so the problem is that you see this thing here, set in stream.
Yeah.
Wait, my screen is not going, so let me share my screen as well. Okay, so this thing here, set in stream. Do you see that when we are doing set, we are using out stuff like this?
Yeah.
Because this thing is not polymorphic, we would have to copy paste and just change these things to set out stream and so on. Like it's so freaking
Oh.
cringe. Like it's beyond, it's unbelievable. It's unbelievable.
They didn't. I don't know. They might, in their defense, if I can do that. Do they
That's the
have this?
problem.
I don't know.
Do they have
I
this?
don't know.
Like vol x equals this.
What do you want to do, Magit?
I want to see if this is a type.
Oh, oh, are you speculating that this is generic for both?
Yes.
Okay.
Because if it is, then we can use that, I
Then it's
guess.
not ridiculous. If this doesn't work, it's like, what the heck are they? What are they doing?
I don't know if this is working because the LSP doesn't tell me, but oh, maybe it's not telling me. I forgot that. How do I
Yeah,
this?
that. Okay, so now
Okay,
we have an
so it
error
is not.
message.
Undefined
Undefined
value
type.
string. In out. Yeah, so this doesn't exist. Ha 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 ha, mas eu tô indo. Okay, so we are gonna have to do this.
We're gonna have. Oh man, I'm cringing so freaking hard. My Natan would be not disappointed with us.
Ah, Natan doesn't have better abstractions in Okama, I would say. So string, and then we do string. Oh, don't need to do this. In, then we do this.
Oh, so you're okay. So this is not gonna remove the boilerplating, I think, but this is gonna make them.
More bearable, at the
Yeah.
very least. Uh,
Uh, by the way, um, speaking of OCaml, I was looking at a chart comparing like the differences between SML and OCaml recently,
Oh.
and I found precisely one case where OCaml is actually more theoretically sound than SML.
Oh yeah. Which is?
Precisely one case, which is actually the arithmetic operations.
Oh.
hmm.
Could you give us an example? Do you remember?
Yeah, it actually has separate arithmetic operations for integers and for floating point numbers.
Oh. Okay.
It does. The okay, it does. That's why the dot, right? The plus
Yeah.
dot,
Plus
for
dot.
example.
Yeah.
Plus dot, yeah,
Yeah.
yeah.
Uh, but how just separating just a function changes anything? Because well, in SML they are also separated, right? They're just generic in terms of the module. Like I have int plus and I have float plus or real,
But
I
you
guess.
also have just plus without qualifying, and that's overloaded.
I do, yes. I have just plus.
I don't have a problem with overloading in the sense of like plus in Haskell works for both floats and integers, but division doesn't. So the operations that matter are excluded from specific types. And I guess this is wrong because this is a writer. I'm starting to think that there's no capital S in here.
Yeah.
Yep. Yeah, this is really sad. Really, really sad. This.
Why would that be sad, Lemus?
Tell me. You tell me, friend. Marin, is it clear now why this is what I was explaining before?
Yeah, it's. I have to agree with that. This is very disappointing.
Very disappointing.
Okay, so oh man, this was funny. But we don't do a lot here yet, right? We're
No,
still
there's
just doing
something wrong. There's something wrong. Shouldn't we call seek at some point in here?
shouldn't we call seek at some point?
Isn't that the purpose that we just added the out in here?
Yes, I'm typing wrong things here, actually.
Loved it. I'm typing wrong things.
So it is the same thing as this. At least the interface is less painful. Not that it matters much, I guess.
This is position, yeah. And this is gonna be out.
Uh, instead of payload, this is the quantity.
Wait, quantity? What?
Yeah, because we wait. Oh no, sorry. This is the thing to write.
Yeah.
Right. Never mind. That's why payload. I see.
We have a problem though. We need this. Whatever size was is not here anymore.
How do we write? Oh, the size is the thing, right? It's the actual value.
Wait, have you tested only reading?
Yes, I did. That's
Awesome.
fine. No, I actually did. I did write. Yes.
Okay. So what do this function expect? Do you know? Well, do you have
I
a
just
function
want
to
to
write?
know.
Oh
Let's
yes,
see.
outstream and a vector. So this is actually to write in here.
Yeah.
Is that the correct order? Yes. Okay, can you test
So
this?
okay. No, I can't actually.
Oh,
You
we
need to
can. Yeah.
test it.
Okay, so just gonna trust that it's because it's type checking. It is fine.
Yes.
Sure. Uh,
Classic.
okay, so we have a very simple layer, which is this data structure here, which allow us to do
Oh, by
seeking,
the
get,
way,
and set.
let's do some. Let's do something here, like signature data, and here we're gonna put
Oh,
vol.
the description of the contract. Yeah.
Yeah.
So do you
String.
know the types? I have no clue. What the heck is position? Is this a thing?
It is the type that it expects to read, right? True, but it's showing here, man.
Yeah, but isn't this annoying that you're gonna have to convert an integer to a position
No,
in the
you
caller?
don't. This is equals an integer.
Oh, okay, so this is
It
just
overlap.
documentation.
Yes,
Cool.
yes. It's just an overload for.
Okay, I can help with that.
Oh, this is actually word. Ah, word. I
I don't
typed
remember.
work and then put.
Functions that we do not want to export, do we put them in the signature?
Wait. Say it again.
The functions that we don't want to export, do we put? I remember having something like local.
No, you
Am
just
I?
don't put in here. Just don't put the
Oh.
seek, for
Oh,
example.
okay. Okay. And then we're gonna have set, and that thing asks for an entity. So, um,
This is not actually an integer, right? This is a
Oh, this is a file
So
path.
this picks the file path, the position,
The
and then
position.
the last one is a word 8
Vector.
vector.
Yes. That's cool.
And then we do. Do you remember the syntax I showed last time where you just apply here? Because otherwise we're gonna have to do this, I guess.
But there is also a difference about like this.
Yes, I don't recall these things, but let's see.
Marinho, do you remember? We saw this on the lectures.
Data set.
Oh, I remember. This is to redact the stuff, right? Because if you have an ADT, it's gonna and you use just the column, it's gonna show the internal implementation of the thing. If you use this, I think it redacts it out. I'm almost sure of that.
Yeah, I have a vague recollection of that, but I don't recall it in all the
But I don't
details.
remember the syntax. Is that in the Harper book, Magetta?
I think it was. I don't recall.
Uh, okay, so we need to find the Harper book, which I already lost. Let
It's
me find it.
everywhere.
So where is the Harper book?
The Harper book.
Harper. I remember you sending it in here in this chat. The problem is that there are many links in here. Many links. Did you happen to download the book, Marinho?
Search like
No.
programming standard ML, something like that. To show up.
Okay.
Robert Harper.
Programming in standard ML Harper. Oh yeah, found it. Okay, so which part of the book do you think the piece of syntax is?
Uh, search for functor. Probably you will find it.
Functor.
Or rather, signature,
Signature.
which is probably 1,000 things on
Yeah,
book.
300. Uh, let's see
I
if.
found the functor, but the thing of the functor is slightly different.
So we want to combine the signature with the structure in a single shot, right?
Yeah, I think it was this.
I have no
Hmm.
recollection of it. Okay, so signature didn't help me that much. I'm gonna search for functor now.
Functor also is not very helpful. That
Well, for now we can keep it like this. It's not bad.
it was something like equals struct, something like this, that you end up defining it,
Mm-hmm.
and then you can define the struct right away, right? And then it goes away. But let's just keep it this way.
Yeah.
I don't recall how it was the syntax. It's just sugar syntax anyway. Okay, so we can now write and read uh, arbitrary bytes. Uh, let me ask a question now.
Sure.
What's the path, right? So our path. Let's see. The intent here was we want to generate something like a usable wall file, right? Something like that. Uh,
Mm-hmm.
the way we can achieve that is by having some sort of distributed storage where the nodes, the individual deployed nodes of this garbage, can go in there and fetch from exactly where it thinks it is, right? I think
Sure.
that's what we discussed last time.
Yeah, it would be like a layer, like a server of sorts
Uh
that
huh.
would allow multiple instances of a database to retrieve data in a distributed manner, basically.
Right. So let's think of what we do next here then. Uh, what do you guys
Oh,
think about? Go on.
I think my Marinho found it. Congrats, Marinho.
Let's see.
So the
Yeah, I found the
syntax
link.
is data
Syntax cheat sheet. Okay, that's great.
there. So we do something like this, and then sig on it, and we put structure
Oh
in
yeah,
here.
it is.
Structure. Then we put our stuff, and then we do an equals struct
Mm,
in here.
and then I delete this. Yeah,
Awesome.
which is what I almost what I typed, but I forgot this. Right.
Cool.
Okay,
Thank you, Manny.
so great. So this is now exposing only this two. So if we do, well, supposedly it is.
Yeah.
So if we do data, hold on. Okay, this top 10 fails in the history of anime. Data. There we go. So you can see here, right?
Yeah.
Okay. So let's just start thinking now what we do next. So I think of some sort of layer that controls. Like, do you recall when we were discussing about a layer that controls the?
Yeah, isn't that the broker or something?
It is the broker, yes. But we need to what goes in that layer, right? It's the knowledge. Like, it's the only part that actually interacts with the disk.
Yeah.
But all the other nodes should share this idea of this section of the broker, right? To read, they can read individually. Otherwise, what's the point of having distribution?
Yeah.
I'm just thinking here of, well, how can we separate these processes?
When you say processes, do you mean the individual nodes, like the clients?
Yeah, think of like one computer running one instance of this and another, and then they synchronize over a mesh in a cluster, and then they can,
Oh.
and then both know that okay, you pinged, you asked the broker to get like this data here that is on this specific, I don't know, partition, right? Partition 10, whatever. But this partition 10 is not deployed in here. It's stored in, like, I don't know, this other computer. So I'll go there and grab it for you or redirect it to the one that knows how to handle this.
Okay, so my first instinct is to make some sort of like how they will communicate. They need to send information across the network. So shouldn't we make like the data format that the client node needs to tell the broker node stuff? Like what do you want? Maybe you should make that right now.
Ooh. So repeat, please. I
Yes.
don't know if I got you.
So when a client node talks to a broker node,
Mm-hmm.
they will exchange some data via the network. What is the format of that data?
I have no idea.
So maybe we should start thinking about that, right?
Yeah, I think, as you said, I agree with you. Like, I think we should define the foundations and then we can do things separately
Yeah.
because that would be the pain part.
Yeah, so I was kind of thinking, couldn't we make something like structure,
Oh, you're here.
structure, and then I don't know, uh, a packet, and then we do some sort of like a data type of a record, which with the fields that it needs to be fulfilled
Oh man,
from
in
the.
Erlang it would be so easy.
Yeah, yeah, that's kind of the funny thing because we have the other side of the coin on Mondays, because we know we are doing Erlang on the other side.
Maybe
So
we should have done the MMO in SML and and this
yeah,
in
but we
Erlang.
we
It
discussed
would be.
about doing that, and the reason we didn't do that is because of the library for the lack of libraries to make visual stuff because you cannot download the source
But
code.
we're not gonna do that in Erlang, right?
No, we're not going to do that in Erlang. But if you want to use SML with Erlang, then the SML would have to do the client
No,
side.
no, no. What I'm saying is, instead of doing Lyceum, the server in Erlang, we should have done the server in SML and then done this in Erlang.
Oh, okay.
Like
So
swapped.
make
You
the
see?
distributed server of the game in
Yeah, I
SML.
mean, it's, well, it's a language made for that, right? It has to be better. But anyway, like, let's just go with this.
Okay, so then I was thinking to make a record, so some sort of record in this part here. So then we can define like, I don't know,
Oh, by the way, hi Fernando. We haven't
yeah,
introduced.
hi
Someone
Fernando.
asking what are you guys doing?
Uh,
So this project started sort of an idea, a very shallow idea, I should say, to start doing a sort of a Kafka, but we're kind of diverging from that idea to do something like a commit log for our database that we can use for some other things. Like
Yeah.
it's a generic distributed uh, layer so we can have some consistency. That's basically the idea.
Yeah.
So we're dropping, like if you pick the cap theorem, we're kind of dropping, I think, the partition
Oops.
tolerance, and we're going with A and C in this case.
But if you drop the partition tolerance, then it's not actually distributed.
You well depend. Okay, I see. Depends on what you call distributed, right? What I'm saying here is just a bunch of nodes. Yeah, in terms of storage, it wouldn't be right. Uh,
Yeah.
let's see.
So then I was kind of thinking, so how do you make a record? I don't remember.
Wait,
I already
just a
don't remember.
second. Let me think here for a second. Marin said something that I got me thinking now. That is right, because if you drop the partition tolerance, then the data cannot be split, right?
Yeah.
So
Wait, could you explain that to me? What do you guys mean by partition tolerance?
so you know the cap theorem.
Not on by the top of my head, no.
Let me see. You're streaming from your screen, right?
Yeah,
So can you open the browser and search for it?
sure.
Uh,
This one?
Yeah. So go to Wikipedia. That's fine. So there. So consistency says every read receives the most recent write or an error. So it's basically the up-to-date data, right?
Mm-hmm.
So it is the correct data.
Yeah.
No eventual consistency. Availability says every request receives a no-error response. So you get a response. It may be wrong, but you get a response without the guarantee that it contains the most recent write.
Yeah, so you
So
may have outdated stuff.
yeah. Uh, just a sec. My glasses. And then the last one is partition tolerance, which is the system continues to operate despite an arbitrary number of messages being dropped or delayed by the network between nodes.
Oh, yeah,
So
so you need this to make it distributed.
uh, that depends on what you see on that, because, like for example, Postgres, it gives you two, right? However, you can mount Postgres on, for example, on a cluster on disk. It will abstract the disk for you, but it's still distributed. There will be problems with latency and parts of the system can die. Uh, so you would have to have some specific functionality for handling this case, like replications and whatever.
Mm-hmm.
But that's not the point we're thinking here. Like, because if we what we want is for the DBMS, right? We don't want what we absolutely want is consistency. That
Yes,
makes
that's
no
what we,
sense, right?
yeah, that's what we definitely most want.
Yeah, like it makes no sense to give wrong data for your DBMS, right? That's this scope. What we want is that.
Yeah.
But then I'm thinking we have to drop either availability or partition tolerance. But dropping availability is kind of weird, right, for a database that not to be available. Although I think it's better than dropping the partition tolerance because we can't, well, not better, but we can't drop the partition tolerance.
I have a question. This
I have a hot
assures.
take on this thing, by the way, but
Okay.
go on.
okay, the problem with dropping partition tolerance is that if you look at the definition, the system continues to operate despite an arbitrary number of messages being dropped or
Mhm.
delayed by the network. Okay?
Yes.
The implication here is that if you don't have partition tolerance and the network drops or delays messages, which it will,
Mhm.
because it's a network, a real network, then the system will stop operating, which means we lose both availability and consistency because the
Yes.
system is not online.
Yeah. Although my question is kind of related to that in some sense, because to me, if we care about this, but we drop availability, we are running the risk that the client will receive inconsistent data at times, right?
No. If we drop
That
availability, you could try to make a request, and
yeah.
then the storage layer that we're implementing will just say, yeah, there was a network failure.
Mhm.
I don't have the latest data, so I'm not gonna give you outdated data.
Exactly,
That's it.
but that's an implication of what I'm saying. Because to me, if we maintain availability, running the risk that we have no guarantees that the client is receiving the most recent write, that means
Let's
that from the client perspective, maybe the outdated
mm.
write is inconsistent with the rest of it.
Let's think of our use case, right? I think it's better than saying dropping availability. What does that mean, right? So consistency says give me the most recent data.
Yes.
Availability says give me a response
Give me something all the time.
all the time. Tell me you are alive at least.
Yeah.
And then the third is uh, there are 10 nodes deployed, and then you drop 9, and I can still talk
Yeah.
to you, and I have guarantees at least that I'm doing
Yeah.
something, right? So let's think of like we're dealing here with storage, right? So let's think like storage. I mean, writing like directly bytes to
Yeah.
files.
Exactly.
So what does it mean to be consistent? That means that we have some sort of algorithm that synchronizes the partition. That synchronizes distributed files across the network, like Reft.
Yes. Yes.
Uh, or you have something like a file
Um,
written on the same place,
a locking
which is
mechanism,
like
right?
kind of sorry, what?
A locking mechanism, right?
Yeah, but it would be still centralized, right? In that case,
Yes. Yes.
which I'm not against, to be honest.
I mean, you could try to implement some kind of distributed lock, but that sounds
Eh, That sounds
Oh yeah.
hellish,
Yeah.
problematic.
That sounds really really hell. It should be possible though. It should be possible.
or maybe not.
No, it depends on how we implement the broker, I guess, because the broker will have to have some criteria to say, okay, so who was the first one that requested for a write operation? Who was the second? And then maybe we can fold all the requests that wants to write into the same table. The same for updates. So it depends on how we implement it, I guess.
Mm.
But anyway, so I think we want consistency and partition tolerance. That's what I think.
Is this all useful at all? Because think of this. In the end, we're gonna have what? Racket Tower running on top of it. Oh, but wait. Then it would mean that you can run many instances of Racket
Yes,
Tower,
exactly.
and all of them would be up to date, right?
So if you have an application running in our service using Tower, and I have one with Marinho, and we want to be seeking the same data, retrieving the same data, the most up-to-date data, we could use this thing to
I
guarantee
see.
that we have the
So
same data.
yeah. Okay, so then let's think of the design, how that would work. We're gonna have to probably separate the file that we're like well Kafka calls partitions, right? Which are the things that he writes to.
Yeah,
Think of like different file strings that we're gonna write to over the same data, right? So you have like people, let's say. Like think of a Racket Tower file, like people.ndf.
yeah,
And then you write people one, people two, people three, and they have different sections of the data, and all of them are monotonically increasing.
sure.
Uh, the part of the monotonically increasing is not even that important, but I think that's it. And then, okay, I think we can start with that. That sounds good enough to
Okay,
me.
Okay, I also think that we should start with that. So what do we need? So let's put the scenario here just for everybody to understand. So we have a racket tower instance one, and we also have another one,
Uh-huh.
and they are supposedly they should be the same thing, right? But this is always hard because clients are poking into my database in my application, and the other clients are
Oh.
poking Mageta's database in his Racketara instance, and we want them to be
And
unified
so now
somehow.
the data is the same for some reason.
Not the data, not but the schema.
Well,
Uh,
yes, yes, I see. Yeah.
so then we're gonna have Canteen on top here. Oops, on top. And then it needs to have a Racketara instance as well because this is going to be like the real source of truth.
Yeah. Well, not. Yeah, I would say not even racket power, like a interface, right? To it. That's what I was talking about. Like you can be racket tower, you can be like a JSON writer. I don't know anything.
No, wait, but then I have questions because this can be whatever database you want, but these three needs to be the same.
Just give me a sec. A sec.
My does that make sense to you? That these three needs to be the same?
I think you might be mixing the layers here.
No, but
Maybe.
that's what I'm trying to describe how I see it, what I was proposing when I said what I said. Because if this thing is
Mm,
not necessarily Racket Tower, uh, how are we gonna tell the two instances that they are wrong? Because we are using, but let's suppose that this is Postgres, right? For a moment, Postgres. Let's suppose that. How will we say to these two instances of a different database
Come back.
that their data is out of date if they don't understand Postgres, they understand these things?
Well, it's not Postgres who is storing. It's Canteen.
Okay, so you're saying something different now. So Canteen has its
Like
own
all the Canteen will
database.
do is pick bytes, write bytes to a file, and that's it.
No,
So
but
like
okay,
Postgres in this case, like think of a database, right? Doesn't matter if it's like a RocksDB or something
sure,
like that. It would have to write a byte for one record, so it would serialize that somehow,
sure,
and then it will send that to Canteen, and then Canteen stores it with a key there, like monotonically increasing,
sure.
whatever.
But then I have a question. What would we return as Canteen to the client?
What we would return to the client. Well,
Yeah,
it's not the okay, what do you mean by return? Because it needs to respond to what call you're thinking.
okay, so let's suppose that Racket Tower Instance 1 wants to write stuff to the disk. Okay?
Let's do. Oh man, do you have like something to draw? I think it would be better.
Uh, I don't actually, but
Do we have a Paint, Linux
draw
Paint?
IO.
Oh
This is
man,
still exists.
there must be a goofy thing for
This
Linux
still
Paint.
exists. I'm very surprised.
Tux
Okay.
Paint. That's it, man. You can use Tux Paint.
Okay, so let's imagine here that we have, yeah, this works
uh, I
here.
think you can use Inkscape as well.
Oh yeah, that's true.
Can I write? Yes. So this is gonna be Canteen,
Okay.
and this is gonna
Oh man,
be.
but it's so cute. Look at this.
Look at what?
Isn't this cute? Adorable. Tux
What
Paint.
is
You
Canteen?
you are not sharing the screen, Mageta.
I sent here the.
Fernando said something.
Yeah. What is Canteen?
You want to know the as a project or as a name?
As a project.
As a project, you said.
Yeah, I think so.
Okay. So our, as Mageta said before, the original idea was to try to attempt to make a Kafka clone, right? So event sourcing stuff, distributed stuff with
Not event
broker.
sourcing, because Kafka is not about event sourcing.
Okay, so broker, topics, and partitions, and we would store that, and multiple clients could be would be available to hook into that. But then Mageta had an idea to swap it which is to make like I think originally Magenta called a locking layer, right? Um,
Name I gave.
yeah, and then we change we want to explore that idea. So we want to have this thing to be possible. What I'm drawing right now. Because what this is basically allowing multiple instances of databases to be synchronized using a distributed sort of system, right? Which is what Canteen should be. And we are now kind of like trying to design the features to see if first if this is useful. Second, if it's possible with SML's limitations. And third, if it makes sense, because at times before we were not sure if this makes sense. I think it does, given what I discussed with Magita. But that's what this is supposed to be. I hope I helped. I hope. Okay, so Magita, I'm looking at my screen right now.
I in.
Okay, so here's what I thought. So we have multiple instances of the data of whatever database, and my question to you is the following: what would an instance of this database do? I imagine that this would request to write something to the database or
Well,
read
the
from it.
Racket Tower 1 would say, I want to write this record here, which is like in
Yes,
our case, in the case of Racket Tower, a row, right? So
yes,
it
we
would
want
say,
to
I want you
add
to write to this file, this guy.
exactly.
And then Canteen goes and says, okay, I'll write it. And then Racket Tower doesn't know where it is. He doesn't care. He just goes there and writes it.
Oh, okay. So in this case, Canteen would it would just have like a local file, which can follow whatever format, and then
Well, it
Racketau
doesn't.
would inform the
The point
location.
is, maybe it's not local because that's the broker, right? So it will go to some node in the network and
Ah,
say, hey guys, which one has this value here? And then,
I see. So we would have like something behind the broker, and these guys are the persistence.
yeah, like each one of these is the instance of the. I don't know how we would call it, but Canteen would be the broker, and then you have instances of the thing running.
There's something inherently about engineering when I'm drawing, man. I don't know how to express
Well, probably because it's fake work.
that.
You should make UML. That would be pinnacle of fake work.
I would say that this is not fake. I'm actually understanding things better, but okay, continue.
I forgot what I was saying.
Okay, you were describing that these things will be the persistence part of what
All
Canteen
right,
would
and
talk
then this
to.
thing yeah. So it can store in multiple computers, whatever. I'm just thinking here.
Yeah, but I have a question. Would these talk to each other?
Well, they from the broker, right? The broker would organize these things and
Uh,
just send in and send back. I would
Go,
say,
Marin.
but we need some sort of like algorithm, like the
Yeah, this is Raft.
Byzantine. Yeah, this is like
yeah,
the Byzantine general.
Go,
it
Marin.
looks to me like where Canteen is now trying to become some kind of distributed file system.
Yeah, I
No, but
think that's better.
that was the proposal of Magetta indirectly.
Yeah, I think that's a better definition. A distributed file system. I
Yeah,
like the
I
idea.
think I agree. This is looking like a distributed file system, specifically for databases. And the way that this is turning out, I think now it makes sense to me that this can be Postgres. If you don't have to be locked in
Oh,
into
think of
Racketower.
this. It doesn't need to be only Racket Tower, right? If we agree with the same format, for example, on
Ah,
Canteen, I can plug my database and then it would interface with Racket Tower.
that's cool. Okay, so uh, well, actually, it kind of depends. I think we need to define the same format for writing rows for all the databases,
Yeah.
uh, which is less complicated than defining a common schema format. I think it's actually much
And
easier
you
to
know what?
settle.
I think going full blown into a distributed file system is a much better idea.
Oh yeah,
If it's a good idea to do this in SML, maybe not. But
no, yeah, but we discussed about that already. So this is gonna be perplex.
By the way, the first one made was Coda, apparently, in 1987.
The first what?
Distributed file system.
Oh, okay, I didn't know that. And let's suppose that this is actually Postgres. And then I can remove this racket tower. Okay.
Hmm.
Okay, I'm liking it. I'm
I
liking
mean, the
it.
license is GPL. That's
Marinho, do you like it? Does this first the three questions, right? I don't. I only think we have answers for two, but the three questions are: does this make sense? Is it useful? And can it be done in SML?
Uh, First of all, I don't like this picture because it makes Canteen look like a single point of failure, which is precisely what we're trying to avoid.
No, but this is still the thing because we have a single broker. I don't know how we're gonna handle multiple brokers yet.
yeah. This is not really the like this is just the it doesn't mean it's physically that, right? I think
Yeah,
that's
yeah,
what
yeah,
I'm
yeah,
really
yeah.
trying to
No,
say.
no, but Marinho is right. These we're gonna probably have to make a raft for
No,
uh,
no, no, no.
persistence
It would
nodes
have to be.
and for multiple brokers.
No, it would be more the case that Canteen would be more like a protocol, and then each instance of Rocket Tower, Postgres, Perplex, whatever, would have a Canteen client, I guess you could call it. And then the nodes of the file system would have a Canteen server, and they and I'm calling them client and server in the sense of, okay, the client is the part
Oops.
that uses the storage, and the server is the part that provides the storage. Not in the sense of this not being like distributed, because it would be like a distributed server, not a monolithic server, I guess.
Mhm. Okay,
Yeah,
but
but then Continue.
go
Yeah,
on.
but then Continue itself would be more like a protocol that they use to communicate between each other, not actually a physical thing.
Yeah, so we are basically putting the storage of any database, if they have a single format of storing the data, they can still have their unique formats for schema. But if they all settle on a single format for the data, they can use this and talk to each other. Yes, it's what you said. Yeah, but you didn't answer the questions though. So three questions. Does it make sense? Is it useful? Can it be done in SML? The only thing that I don't know is the third question.
Yeah, I would say yes, yes, and I have no idea.
Mageta?
He's muted.
Yeah, Mageta is muted. Fernando, does this make sense to you as well?
Not gonna lie. I'm just lurking here.
Okay, that's cool though. Um, okay, but I do think this makes sense. Okay, so while we wait for Mageta, Marinho, let's talk a little bit about the how we're not gonna make this because at first glance I think it would be reasonable to actually implement these guys, right? And you are right, Canteen would be working as a single point of failure, but I think that's a very reasonable first implementation.
Yeah, that's the thing. If you want this thing to actually be distributed, then Canteen has to be a protocol. It can't just be like a single gateway where all communication passes through it.
When you say that Canteen needs to be a protocol, are you saying that we need to have multiple servers communicating with this protocol?
Uh, well, not necessarily. What we need to have is the file servers. They need to communicate with each other, and they may have an internal protocol. And
All right.
then the clients, which use the storage, will communicate with the servers, maybe using a different protocol, maybe not, maybe the same. I don't know. We can decide that later. Uh, but the point is that Canteen would not actually be a physical thing. It would be kind of like the language that they use to talk to each other.
Mm-hmm.
No, but let me be more specific about my question. My understanding is that Canteen would be actually a bunch of, well, yeah, let's use these. It would be a bunch of servers here in another protocol communicating among themselves. They are all brokers. But you don't know
Why do
that
you need the brokers in that case?
because the brokers are as far as I was discussing with Mageta, the brokers are actually what the clients talk to.
Why can't the clients uh, why can't the clients just talk to a node, a server node, whatever one is closest to them, I guess. And then the server figures out, okay, I need the client asks me for X. I don't have X, but I know another node that
I
does,
think
so let's
that's what
see.
Oh,
Lemos means by no. Well, okay. What I understood, right? Like for example, on Kafka, you have many brokers deployed, and then you talk to the one that has the lowest latency or round robin, whatever you put the policy.
yeah.
And then when it gets there, it says, okay, I know who can give you this information, and then it does all the routing internal, and I don't care for it. I just communicate to whatever,
No,
right?
no, no. But here's the difference, Magita. What Marinho is proposing is that instead of having a middleman in the middle talking to the clients,
No,
the
but I didn't
client.
mean a middleman. I meant
No, but
this
I
thing
meant
would be
that when I explained that to you.
what I understood was this middleman that you're talking about is a set of utilities that are diluted on each node.
Yes, yes, it would be. But I was more thinking about a differentiation between persistence nodes and communication nodes. What Marinho is proposing is that each persistent
Don't
node
the
can communicate with the clients, and they also have the raft among themselves, so they can talk to each other to retrieve the data that you're looking
Yeah,
for.
that's what I meant.
Okay, so then I got it wrong then. In that case, Marinho, you are completely right. Canteen would be a protocol and not actually a physical thing. So, okay, so we need to decide. We need to decide that. Mageta, uh, I really settle on the idea then that each
Yeah, I
individual.
think this is a much better idea than what we were going for.
Yeah, no, but I want to go further. Uh, are we gonna then do what Marinho just
Oh,
proposed, which is that each node that communicates with any client, it has persistence and it does the broadcasting if it needs.
well, if we want to achieve the goals, right? I don't think we can run from those. So yes.
Okay. So in that case, we need to define two things for starters. We need to define what is the data format that goes between a node and a server node and a client node. So probably something that will be serialized to JSON, but probably we can make some sort of like a data type in SML. And what type, which information they need to exchange between each other. We need to discuss that, and we also need to implement some sort of Byzantine thing for the now persistences and communication nodes, which I think we should go with Raft because why not?
Mhm.
Uh, and then we need to implement one of these, and then implement how they in test they talking to each other like this, and yeah. So are we settled on this then? Does this make sense? Is it useful? And can we do it in SML? Those are the questions.
Well, the last one is the problem.
What do we need?
I mean, we can. Well, I mean, we can do most things in SML. The problem is, can we do most things easily in SML? That's the
Um, I know. I think you know who I am. You know who we're talking to. So I'm not. You know the answer to that question.
The
man. I just
famous
don't want to like be stuck on stupid issues. Like I sorry, if we are gonna do that, I would rather just go with like C at that point.
Oh, so if you
Not
want.
that I'm saying we should go with C, please, no. But you got the point, I think.
No, but I think this should be doable in SML. Am I dreaming?
I don't see anything that it doesn't. It's not. Yes, I don't see anything that it's not. But
Yeah.
can't think of it.
So these guys are talking to each other.
And you are perfecting this too much, Lemos.
No, but it's a free tool. I'm gonna
And it's
get a
not. It's
print.
it's kind of tilted.
Is it tilted?
Fix the second arrow, please. A little bit up. No,
There.
yeah, that's better.
Okay. Uh, but they don't know that, right? So we need we need a gigantic circle. They don't know that who they are talking to.
Well,
I
you actually do.
do they?
Yes, you communicate with one of these brokers, right? That's
No,
the
no,
whole
no. But the
point.
client don't know that. They don't know that.
It does.
No, for them
These
it's
are all
transparent. They don't.
deployable.
For them it's transparent, Magita.
Man, you're talking to one node. That's the transparency layer. But to communicate, you're communicating with one of those little balls.
No,
The
I know
it's
that you
not
were
a
talking
macro
to.
thing
No,
on
I'm
top
not.
of
No, but
all
I'm
of them.
not. I'm saying, does Rocket Tower knows that it's talking to node number one, number
It
two,
does.
or no? Oh, it does.
Yes.
Okay, I didn't know that. I thought we would make that transparent. Why we are gonna
It needs
allow that?
it needs to know because ideally you want to choose the one that's closest to you,
Yeah,
right?
you
To
want to
Oh,
do
minimize
some.
latency.
Yeah.
oh, okay. So there is latency concerns. I forgot about that. Okay, so this is the picture, right? This is the
Yeah.
picture.
Yeah, the point is not that you don't know which node you are talking to because you do. It's that you don't care which node you are talking to because
Yeah.
every node can communicate with
Can
all
do
the
the same.
others ideally.
Yeah.
How each client will know which node to talk to? Like you said, oh, the one with the best
Oh, that's
latency.
the concern of the connection library, right? It will be like whatever. Like
Oh.
I have this policy here of doing like I don't know round robin, and then you have a traffic statistics on which node. So I'll
Mhm.
pick this one instead of the as pick node one instead of two because it's like less congested. I
Cool.
don't know.
So here's the drawing, the professional.
That's well, you're not using the correct things of storage, the design,
Oh
right?
no, yeah, but I should use these ones, I think.
Yes, the cylinder.
Yeah, no, but imagine that it is from an up perspective, you know. So this is a cylinder, but it's you're looking from the top.
Oh, next step is to make an UML diagram, and then you produce Java code from this. And then you produce 10 Jira tickets at least per
Okay, so
feature, and then you can start
here's the
working.
question: what do we want to? I want to list which things we need in order to judge, at least try to judge if SML is capable. We need networking capabilities.
I need to read about distributed file systems, but just speaking a thing here. File transparency. Users can access files without knowing where they are physically stored on the network.
Yeah.
Load balancing. The file system can distribute file access requests across multiple computers to improve performance and reliability. Data replication. The file system can store copies of files on multiple computers to ensure that the files are available even if one of the computer fails. So
Yes.
that's pretty clear. Security. The file system can enforce access control policies to ensure that they only are authorized users. It's kind of I don't know if I would attribute this to a distributed file system. Like this is
Encryption?
certainly a feature. What? Sorry.
You no, are you reading encryption?
It's not encryption. It's just enforcing control policies, right? So
Oh.
it's access,
Oh.
which you well, it's not a thing of distributed file systems, right? It's just general file systems.
Yeah.
Yeah.
Scalability. Oh man, I hate this word so much. The file system can
Hilarious.
support a large number of users and large number of files. Concurrent access, so multiple users can access and modify the same file at the same time. This would be hella useful for a database.
Yeah, it sounds very useful. uh,
Yep.
Fault
okay,
tolerance.
go.
The file system can continue to operate even if one or more
Could you
components
send me
fail.
that link to so I can put it on the screen?
It's literally geeks for geeks, man.
Oh, so
Like,
distributed
I'll send here.
file systems.
Geeks for geeks.
Uh, what is DFS? Yes. So
Scroll when it search for macOS DFS.
Mac OS.
Separated, right? Mac. Yeah, there. This. You were there.
I was there.
Yeah, these properties. These properties.
Scalability. Go on.
So there's this, but it was on the other part that you were.
Yeah.
So
Here.
because they have the same names. Yes, these properties.
Mm-hmm.
I stopped on the scalability.
Yeah.
File system can support a large number of users and a large number of files. That's
Yeah,
fine.
that depends on how many nodes and which algorithm you're using.
Yeah, but the
Multiple
point is
user.
that you want to be able to add more nodes so you can store more stuff and have more users accessing it at the same time.
Oh yeah. How in the crap are we gonna test this though? Are we gonna
Oh,
like buy a server in Europe just for
oh,
lols?
man. Why? No. You just deploy multiple things on your very computer.
No, but then I'm not testing if the algorithm is working better with the latency between geographical distant
Oh, then
servers.
you go to Oracle and then you get a free VM and then you host a thing there and you connect to that. Like that's it.
Okay.
You order a like I don't know Oracle in Singapore, something like that.
Okay.
Uh, the file system can continue to operate, whatever. Data integrity. The file system can ensure that the data stored in the files is accurate and is not being corrupted. File migration. The file system can move files from one location to
Oh.
another without interrupting access to the
These
files.
sounds like a bonus features for us. This we wish like the version 2.0 should have this. That's cool.
That sounds hellish, to be honest. Data consistency. Changes made to the file by one user are immediately visible to all other users.
Yeah.
Man, doing this on a database, it already gives you a free pass to implement transactions.
Yeah. Pretty much.
Because that's my main pain on handling transactions right now. Because you basically have to either go on so Postgres, for example, calls serializable, which is eliminates all the problems with like phantom reads and all of that stuff. Or you go dropping, but then you go losing precision. And either way, it's hard to implement. But if you have this thing that is already hard to implement, then at least doing the other part on the database is easier.
Yeah, but I'm reading this and my understanding is that what we need to do is very clear, crystal clear to
And
me right now.
just something, just one note here. This is beautiful because that means that the database will actually do what a database is.
Who would
It
have
will,
thought?
man, which is not dealing with storage at all. Like it is just a set of just organizing a set of predicates and allowing you to run things on it. It's not about just storing things on the disk and making the programmer concerned about where the things are stored.
No,
This is
wait.
promising.
No, wait. I'm very confused because as far as I can tell, what you said a database should not do is exactly what we are doing here.
No. Yes,
Because we're
but this
not
is not the
implementing the
database.
database, we're implementing the file system.
Exactly. That's the concern of the file system, not the database. Search for data independency.
Oh.
Actually, there's a good page for this. Search for project M36
No, I know
on
what you're
the
talking
GitHub.
about now. I do know what you're talking about because you're
Let
saying
me. Yeah, search for data independence on their page. They have a good
they
thing.
have a page.
We go there to the main thing. Yeah, search for independency on this file. On
Oh, in
this.
this file.
No, not only file. Yeah, there. Data independence markdown. What is data
CG
independence?
dates, right?
Yeah. Certainly, most SQL products have failed to live up to their relational model's full potential. In those products, what the user sees is what is physically stored are essentially the same thing. In particular, it accounts for the argument, so often heard, to the effect that we have to denormalize for performance. Like, this argument, denormalize for performance, doesn't make sense because normalization is
Oh,
not about.
we are. I'm gonna use that word. I know you're gonna hate it, but I don't care. We are decoupling the writing from the
I
logic.
mean, that word is banned from my vocabulary. I use deep pairing. I'm not sure. I'm not joking.
Deep
I
pairing.
say pairing. Yes. Whenever
That's
I need
just
to
a
say
semester away from despairing.
What a trauma. But okay,
yes,
so we are separating the relational algebra slash logic from it, from the actual what takes more time, which is actually writing and reading from the disk.
yes.
So
I'm
so
Oh,
gonna
that
take a nap.
it's not even the most. Sorry, Fernando.
I'm gonna take a nap.
okay.
Okay.
But I really like the project.
Yeah, thank you. We are trying
I
our
hope
best.
this will go far. This looks cool, man.
It if depends on me, you know it's gonna go at least 1.0, Mageta. You know me. Uh,
Let's hope, I guess.
and we
Bye,
have
guys.
bye,
So yeah,
Fernando. See ya. So
thanks for
we and
dropping by.
we have the skill. We have Mageta, we have me, and we have Marinho.
Oh
Mageta
man,
has the knowledge.
we're
Oh,
like the Avengers on this project.
yeah,
I
no.
like the idea.
Okay, so here's the thing. Uh, so that basically means that if we have performance problems, we can swap the file system but maintain the relational part of it.
Bingo.
Which,
And all the burden of like this performance bullshit is not all of it, but most of the performance complaint will go to the file system, not the database.
yeah, that's precisely the point. I think I like it. I really like it. Uh, okay, so for me, in order to judge if this is possible, like doable in SML, we need to discuss
You know,
how to implement
I
rect
have
in
an
SML.
idea that might be good. Do you guys know Merkle trees?
Uh,
I know them a little bit.
Merkle.
That's not
oh,
how
Like
you
you know
Merkle.
the
spell that.
it's actually Merkel lemons, like
Mer.
Merkel. You know Merkel, the Angela Merkel.
Is it like this?
Yes, I think it is
No,
that.
it's
I-
spelled with an
This.
E instead
It's
of an
yeah
A.
with an A. Yes, Merkle tree. So this is basically what Project M36 uses, and this thing's and why do they use it? Because it creates and Git uses this too, by the way. So it's like a distributed thingy because each change will be under a hash. So you will have like the beginning, like a master, and then you can go branching. You see, like hash zero. Look at the image on the left, on the right. So zero, hash zero, and one. I'll wait to open.
Open here.
So you would have hash 0 and hash 1,
Mhm.
and then you would expand that into like other leaves, you see?
There's a problem though. It's saying here that it's using a cryptographic hash. I don't think we can do this in SML, can we?
It doesn't matter, man.
Not that we
I
need
think,
to, because SML can call somebody else to
I
do it.
mean, yes, like I don't think this is a concern. We can, like, in the worst case scenario, we can make I don't know, a C thingy and embed it. So that's fine.
Yeah,
Yeah, just import libsodium and use SHA or Blade or whatever.
that works.
But look at the data blocks. Like, this is where the actual information is. But to access it, you can go over the
This is
time.
so cool. So each server node would have one of these.
Well, this is the entire. This is like the schematics, right, of how the data is. It's like Git.
Yeah.
Like you have branches, you have the
No, yeah,
commit,
but
and you have the
what you're
storyline.
basically saying is that we can have multiple strategies on how to do the persistence.
Uh, yeah, I think so. Yes, this is one of them because it allows you to rewind in time. So you
Mhm.
want to go back to the data that existed at this time A. Yeah, go ahead. Just give me the SHA, and then you go back.
Okay, okay, but this is like a,
Oh,
a,
like
a separate
go down a bit.
conversation.
Let's see the uses. Oh, look at that. ZFS and BTRFS implemented.
Yeah, it's a file
Bitcoin.
system.
Bitcoin uses it.
IPFS
Peer-to-peer.
is a good example because IPFS is in fact a distributed file system.
Nix
And
and geeks,
NoSQL and geeks.
of course.
Hash tables can be used to verify any kind of data stored, handled, and transferred in between computers. That's exactly what we want. They
Okay,
can
so
help ensure the data blocks received from other peers in a peer to peer network are received undamaged and unaltered, and even to check that the other peers do not lie and send fake blocks.
Okay, so here's my pitch. What we need to have in order to make this dream happen, we need network capabilities to implement Raft, and we need something that allows us to use some sort of this. In the worst case
Well,
scenario, you can
if
use
we,
C.
I don't think we need Raft if we use this.
No, but we need to communicate with each other, right? This is what each node is holding, as far as I understood.
This is a schematics that all of them share in common.
Yes, but how do they share it? They need a protocol to communicate that, no?
The the protocol to communicate that.
Yeah, each one of them is holding one of these. That's my understanding.
They need to synchronize, that's for
Yes,
sure.
exactly.
But
Uh,
this is already synchronizing.
This
Like I
is
just read
already.
there. They can help ensure the data blocks received from other peers are received undamaged and unaltered, or even check if the other peers do not lie and send fake blocks. And I read the other part.
Yeah, it's because the hashes of the leaves of the tree are the hashes of
They
the
are
contents
dependent.
of what you have stored, right?
Yeah, and they depend on each other, right? If you go to the image. Yeah, hash 1.0 plus 1.1. And then we scroll up.
Wait.
Hash
Wait.
0. I don't know how this tree works, by the way. I
Yeah,
don't know
no,
yet.
but I have a very important question. Are you proposing that each node of the network, a server node, would be one of these rectangles?
No, that's
No,
not quite it.
this is just a versioning of the
Yeah,
data
that's my
on time.
understanding. Each node would be holding an entire Merkle tree.
Yes.
So that my question is, I have a Merkle tree, you have a Merkle tree. We are both each node, one node. How do we exchange information to check if we have the same up-to-date information?
Oh, I don't know. I have no idea.
No, that's what I'm understanding what Raft would do.
I don't know if we need Raft or it is already part of what the one of the properties of the tree. That's what I'm saying. Like a merge, let's say, of the tree. I don't know if it does
Oh,
that.
A
okay.
Merkle tree is basically, you know how in a regular tree you have pointers?
Sure.
Mhm.
Yeah, a Merkle tree, you get rid of the pointers because you want to distribute it, so pointers don't quite work. And instead, you use cryptographic hashes of the contents of the thing that you intend to reference.
Hmm. But does that mean that we have some sort of operation? Because Magetta is proposing, well, Magetta is speculating that this tree, by its nature,
Oh,
has a
I don't know that,
synchronization,
but yes.
and synchronization
Yeah,
thing.
because for example, the same way that you have merge on other things that you can merge two trees together, maybe there's something like that, but I don't know. Like maybe the tree has a magical property that gives us some synchronization, but I don't know.
We
We
would
need to
have to
read.
study this.
Yes.
Okay,
Second tree
but
magic
anyway,
hash.
that doesn't matter to my point. My point is I want to try to do a checklist of what do we need to be able to do in a programming language, any programming language, in order to make this happen. We need capabilities of networking, right? Whatever how we're gonna do it using Raft or not, doesn't matter. We need to be able to do networking, exchanging messages across the network. Does XML have that?
It does have network. Yes, like
Okay.
TCP.
Okay, we need also, we already know the answer to this other question. We need capabilities of writing to the disk. We already have that. Um, what else do we need? We need a way to have cryptographic nonsense, but we can use C for that. Because we can just make bindings, I think, right? If we cannot, we don't have like embedded in XML, we can just pick a C thing and make bindings and embed into a canteen. So
Yeah,
that,
just import sleep sodium or something.
yeah. I guess we have everything then. I think this is doable. What am I missing?
How the world turns. We started wanting to implement a collection of
Yeah.
cryptographic primitives, and then we decided that would be
We're back to
invisible,
it.
so we switched to a Kafka clone, and then we realized that actually what we really want is a distributed file system, and to do that we need cryptographic primitives.
Yeah. What around? All the way around. Okay, so I think we're settled, guys. I think we found exactly what we want to achieve, and I think now that we have this, we can finally start talking about what are the abstractions that we need. Um, yeah, and I don't know. So we need a server, right? We need each node is going to be a server. So we need to make that server. It's going to have something very close to this, like entry point and whatever. And just
Yeah.
for the joke, I want every single instance of the server to be called a can, just because. Uh,
Wow.
just to make the joke. Just to make the joke. Uh, and then we need to decide what the client nodes and the server nodes, what would they exchange, which is what I was drafting here. I called it packet, but it could be whatever. Magetta, do you agree?
Yes.
Yes, I don't know what I'm getting into, but I agree.
What do you mean? Do you have any questions? What did you didn't get? What you didn't get?
Well, no, just like saying, oh man, this is not gonna be easy.
I think it's gonna be fun, which is more important.
Nothing worthwhile is ever easy.
That's a classic one right there. Uh, okay, so let's actually try to draft some stuff. So in terms of a server working in that environment, which type of functions are we interested in?
Well, at the very least, we should be able to tell the server, I have some data for you to write,
Oops.
and also I want to look up some data.
Okay. No, are you sure this is a server thing? I was more thinking about communication stuff.
Oh, communication stuff.
Yeah.
Um,
And you're not gonna define the functions also. I want to make the signatures of them.
signatures, okay. Uh, right. So ideally, gets taking a string and a position.
No, this is just an
Um,
example that I copy
oh,
pasted
that's
from
an
here.
example. Okay. Yes. So ideally, we should be able to say, hey, I have, I want to read a file.
I was more
So we
thinking like
should
handle
have some
request.
kind of read function to call on the server.
No, but the read functions we already have, right? This is the get function. Because remember, the
Yeah.
servers will have a storage like embedded in them, so they will have this structure. All of them will have these capabilities already at some point.
Okay.
So I was more thinking handle request, and we need to be able to do this also between servers and between servers and clients. So I was more thinking like vol handle. What's the difference between a client and a server? I have no idea. What
Uh,
name would we handle client? Let's say handle client, and then this would be handle server. I don't know. And then you would receive some sort of like a payload, and this is just a server, and then you would do something with it. I'm gonna put you with it for now. So I was more thinking like this.
Can.
Yeah. Marinho, am I expressing myself better? Did you understand what I'm aiming for here?
yeah, that would be more like how can I say this? That's like the functions that you would call to set up a machine as a server, I guess,
Exactly,
right? You need
exactly, exactly.
right, right.
So Mageta proposed an entry point before. So what about like start? And then we do unit, I think. So this would be doing like setting the port, IPs, whatever the crap. I don't know.
Hmm.
Mm,
What else do we need?
man, I
Close?
think
Sure, go Mageta.
hello client. I didn't get what handle client and handle server. What's the distinction?
The distinction is that one, well, that I'm proposing at least, is that one function would be responsible for treating messages coming from other servers, some
Mm-hmm.
other nodes, other cans, right? And the other one would be when Racket Tower is communicating with you, or Postgres or Perplex, and they would behave differently. So I'm just proposing to have a separation between them.
Yeah, the handle server would be more used for like synchronization
Yes, exactly.
and
And
movement of
demanding,
files
right? Because
and
maybe you don't have the stuff that the client is asking for. So maybe you need to ask somebody else
yes.
to retrieve it.
Yeah, like if you notice that, oh, this client is frequently requesting this particular file, let me talk to this other server and request a copy so I don't have to communicate just to provide it. Something
Yeah,
like that, right?
pretty much,
Right, I see.
pretty much. And because this is also a server itself, it has a start, so it sets configuration and starts listening to whatever, and then it has a close, which means it's gonna close the connections and remove some garbage or whatever. So this is what I'm trying to propose. Like let's try to make, because we have types differently than when we were doing Racket Tower most of the time. We can start by the types here, just that. So we can try to make the signatures for all of the data structures that we need, and
I
then
need to
next
use.
sessions we just keep going and implement them.
Ah,
So ideas, people. So what else do we need for a server?
mm, dun, 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 dun. That's a good question.
Yeah.
I
It is
don't
a
know,
good
man. Like
question.
this sort of question that I think I would just be able to answer when we start doing. And I need to read about how we're gonna deal with the. I don't need. I don't know what are the communications you see that we're gonna need up front.
No, yeah, we're gonna study that. We're gonna read that. That's fine. We're
But
gonna hear about.
still, I think better than starting with communications is doing the machinery before, like what we did. Like you write to the disk first, and then you like
Oh, yeah, but
implement
we
the
already
tree.
did the. Oh, implement the tree. So you want to go with Merkle trees first?
Well, that like let's study how the tree works, see the properties that it gives us, and then see if it's worth right.
Okay, that
Something
makes
like that.
sense. Okay, I'm gonna put a comment here. So that this we need to define what is the data bit exchange being exchanged between the parts. Oops.
By the way, folks, I think in like 10 minutes I'll have to leave because I have to wake up at 6 tomorrow.
That's fine, but we're almost done. That's completely fine. So
Ah.
I think, Magetta, that you can commit this as it is. I think we have a plan.
Oh, it's unsharing, right?
Oh no, before you commit, I'm gonna actually put the print screen that I had in here as well. So we're not gonna forget what we decided today, because forgetting is a problem, and we should not forget about it. Let me go to screenshots.
But I like this idea way more.
I'm
What
glad.
about? I'm thinking here.
So let's see that this is the design. Squares and arrows.
Let's make a docs folder. Can you make a folder?
I believe so. Docs.
Yeah, let's put it in there.
So there. Move. Let me put my screen back on. So here's the, oh, I don't have the extension to see images in VS Code, but the print screen that I added is in here.
That's what
Um,
what?
you can commit all the changes that we did, and I think we have a plan. So what we need to do until next Friday, we need to read about Merkle trees to discover if you can rely on them, if they are worth the effort.
Oh, read two things, right? Distributed file systems, Merkle trees, and try to understand how Merkle trees help files
Let's actually
distributed
write
file
that
systems.
down. So let's make some to-dos.
Oh,
So,
send that on the channel instead.
oh yeah, we can make that in the channel, yes. Okay, so you can commit right now. I'm gonna
I
actually put
read
the to-dos
already.
in the thing.
It's up there. I think I'll try to do a file system in SML myself, like a normal Unix clone file system. I know it's not exactly what we will do, but
So
I'll try to do something like that.
study distributed file systems. To do study Merkle trees, and finally uh, study properties of Merkle trees. Okay, but now we are settled, right? So everybody's convinced that this idea is good
Yeah,
enough.
and I'm much more motivated to this idea than doing a Kafka, to be honest.
I bet.
It's more
Yeah, this
useful.
one is much more. Yeah, this one is much more obviously useful. Like, yeah, sure, we don't want to care about where the data is stored, and we want some redundancy and all that. Um, so we need to implement some kind of distribution mechanism for the data. And then we can connect multiple databases to the same data through this distributed network of storage nodes.
And we can even make a garbage database, like a Redis clone, something about RoxyB clone.
Sure, bud. Sure. What really is like boggling me is the fact that I never thought that you could have completely different relational constraints, like in the sense that maybe Postgres has a quirk that Racket Tower for sure doesn't have, but they can continue having their quirks if they have a single format for the data being stored. They can share it, even if the logic between them is completely apart, you know? I never thought of that. That's cool. So it's exactly what Mageta said.
Yes.
We are separating the persistency from the logic. So that's so cool, man. That's so cool. I love it. Go, Marie.
No, I was just gonna say, like, this is actually very interesting to me as well, because I do have an interest in like decentralized peer-to-peer computing in just in general. I think that's a very interesting topic, or I guess I wouldn't call it a topic because there's a lot to
I
it.
thought
But
you would make a joke there. I'm so glad you didn't.
He can still
no,
make a
I'm
joke.
just
Please don't give ideas.
I could, but I don't feel like it.
Okay, so I'm gonna stop the recording now.